It's one of the best conferences I've ever been to. It's very, very intimate, kind of a small crowd, really great conference. So if you have any kind of ideas, definitely put the call or submit some talks. Very good. So just a little bit about me. My name is Rob Schieffer. My Twitter handle is Chief7. I recently became a MVP. I run the Birmingham.net meetup. I blog at .net Catch. I work for EBSCO, which is why I'm here actually. Every quarter I come up. We have a big office up in Ipswich and have several hundred people up there. So we've got a bunch of meetings this week. So called Warren and said, hey man, I'm going to be up that way. Do you need a presenter? And he said, yeah, come on. So thanks for having me. But just a little bit about EBSCO. I've been there about 10 years and we have over 500 developers now, big office in Birmingham, Alabama, big office up here, and then offices around the world. I work for an internal business systems group. So we have hundreds of applications and services that we manage primarily on the .NET stack. I'm a system architect now. I've been doing that for solution system architect for about 3 years. And one of the coolest things that I've done since I've been there is about 3 or 4 years ago, we started moving toward continuous delivery and having more of a DevOps mindset. And so really that's where some of this comes from, and we'll talk a little bit about tonight. So why use Chef? How many people are familiar with Chef? I've heard about it. Has anybody used it before? A little bit? Yeah. Okay, cool. So we'll run through some introductory stuff on that. But basically, it helps you automate infrastructure configuration. So the reason why you want to do that is because manual server configuration is slow and error prone. Everybody's heard all this before. It sucks, right? But with automated infrastructure, you can do things more reliably, more consistently. You can schedule it. You can automate it. It's a lot faster. And that's what Chef and DSC provides. How many people have done DSC or are doing DSC? Okay, so very similar. We'll talk about some of the differences there. And then specifically for this talk, because I come from more of a developer background, I'm very accustomed to test-driven development, to unit testing. And so we'll talk about how that kind of helped me get into this technology. So just a quick intro on Chef. It's infrastructure automation with Ruby. So it was, I think they were founded in 2007 as a company called Opscode and have kind of grown since then. But it offers automated and repeatable server configuration, helps to avoid configuration drift, it allows you to version your configuration, and it's all testable. So the different components to that, and you can kind of see that visually on the right. There's the workstation itself that Chef provides. It's called the Chef DK. It's a single download. You install it. It gives you everything you need to start to develop Chef cookbooks. So it's got several components in there. We'll look at that. Then you have the Chef server, which is a kind of a central point where you can manage all of the things that you want to configure. And then lastly, you have the Chef client, which is the agent that runs on each node. So some of the components in that Chef DK, Food Critic is a syntax checker. Kitchen is the testing framework that we'll look at tonight. Chef Spec is a policy management and integration testing framework from Chef. Inspec Chef Spec is the unit testing framework. Inspect is the policy management, sorry. And then you have the recipes and cookbooks that are actually the configuration code that you write within the Chef DK. Part of Chef DK, it also installs Git and Ruby and all the gens that you need. It's all embedded in that Chef DK, which is really, really nice if you're not doing Ruby or any of those things on your own. Do one install, everything's there that you need to get started. Chef server, there's several components to that. It's got a registry of cookbooks that you can upload your cookbook to. They've got a data store where you can set attributes by server and role and different things. You can search, and they have reporting, provides high availability if you can configure it that way. It's got an API. The supermarket is kind of a repo where you can search and find cookbooks that you can use. If you need a private repo, there's a public one as well. The run list is the list of cookbooks that you want to install on a given node. And then they have policy management as well. Chef server is free. I don't actually go into it in this slide deck, but Chef server is free, Chef client's free. There's a bunch of free cookbooks out on the supermarket from Chef. All that's free. The part you start paying for is they have a tool called Habitat that's new. I believe that's free too, but there's I guess a more advanced management server called Automate, Chef Automate, I believe. That's what they charge for. But if If you just want to get started, we use this in my group, and we don't use Automate. We just use the Chef server and the Chef client. So free to get started and free to use. And then you have the Chef clients. So initially when they wrote Chef in Ruby, it was primarily for Linux boxes. And so over time, they started to hear the outcry of Windows developers and operations folks everywhere. Said, hey, we need some of that goodness too. And so they started building that in, but it came pretty slowly. I started getting into it about last fall of 2016, and it seems like 2016 may have been kind of a turning point. I don't know if you know Steve Morawski and Matt Rock, who are very active in the Chef community. They were employed by Chef. They both were. Steve's now working for Microsoft, but they really jumped in, and their focus was really on the Windows side of Chef, and did a ton of work to build the community and to make Chef Windows a first-class citizen on Chef. But it did come slowly, and so meanwhile, Microsoft's kind of kicking butt with PowerShell. They build DSC, which has a very similar function, right? Is to be able to automate configuration of servers. And so what was neat was, instead of Chef competing with that, they said, yeah, that's great. If you can write DSC configuration with Windows and PowerShell, we can run that for you. And you can use all the great tools that are around Chef that had been around longer and had more enterprise type features like the Chef server and all those things. So they integrated that in, and they built resources to run DSC resources. So you've kind of got two different types of resources. You got the ones that Chef built, and there's lots of Windows specific ones like the registry key resource. They have all kinds of stuff, MSI package installs, all kinds of things. But then they also extended it and wrote the DSC resource where you can take any DSC resource from the PowerShell gallery and also run that in the context of Chef. And so that's what we're going to look at tonight. So, but the question I often get is, well, if DSC kind of does the same thing, do we really need Chef? And you get a lot of value out of the reporting and the roles and environment management, the admin UI, and the attributes from the Chef server. So there's definitely value there. All right, so let's take a look at a Chef cookbook. Do I see that okay? Do I need to make it bigger? All right. It's a little, okay. Let's see. There we go. Better? Good. So when you get started with Chef, you get some CLI tooling where you can start to create things. We'll look at some of that, but there's a command that you can run to create just a basic Chef cookbook. And so that's what I've done here with Acme WinWeb. And so we'll start looking at that. It gives you most of this folder structure. I've added a few things, but not much at all. The first thing you want to look at is this metadata file that gives you metadata about the cookbook that you're writing, the name of the cookbook, who maintains it, the license, the version. Version is pretty important. And then you can put all of the other cookbooks that this cookbook depends on. So one of the things that we're going to do is install PowerShell 5 in the context of this cookbook. So I'm depending on the PowerShell cookbook that Chef wrote and is freely available out on their marketplace. And that handles installing Chef, configuring DSC if you need to do that, installing other versions of PowerShell. So you would list any other dependencies that you have there. The next thing you want to know about is the Burks file. So there's a tool that comes with Chef called BurkShelf. And so it's a dependency management tool to use with Chef. And so when we say we need PowerShell for our cookbook, it's the thing that goes out and downloads that from the marketplace and makes sure that's available in different contexts. And so here we're telling it what registry or supermarket source we want to use, and we're just going to use the public one. And then I'm indicating that I have all of my depend statements in the metadata file. So important to know that. Then we get into the actual recipes. So if you haven't noticed by now, Opscode and Chef thought that they'd be cute by using kind of the Chef naming structure. It's cute, but it really sucks when you try to look and search for things regarding Chef. You get a bunch of stuff from Emerald and you know, all these famous cooks. But you know, they have the recipe there, which is a subgrouping or a submodule for installing different components. So if we look at the PowerShell cookbook, for example, they've got a recipe for PowerShell 4 and a recipe for PowerShell 5. It's just a way to logically group the different code that you have. So in this case, we have a default recipe, here, and we'll kind of review this quickly. Just some boilerplate comment stuff at the top. They have helper functions for debugging statements or throwing warnings or just informational data. That you can do, because it's all Ruby, you can do variables, and they have other helper methods. In this case, I'm getting the Windows version and evaluating that to see if it's less than Windows 10, and we'll use that below. Then we actually include that recipe from the PowerShell cookbook. So the syntax here is the cookbook name, : the recipe name that we want to run. We only want to do that if it's not Windows 10, because Windows 10 already comes with PowerShell 5. So just a little bit of a little example of some of the logics you can start to build into your cookbooks. Next, we have a directory resource, which is a resource from Chef that allows you to create directories on the target node. We've created a variable here called log folder, and then we're using that as the path for this resource. We're giving it a name, and we're setting the action to create. So this is a very basic resource that you would use inside of a recipe. So I've set up this demo to not require a internet connection, just in case. So some of this code is commented out, but we'll uncomment it here just for example's sake. So this is an example of where you would use a DSC resource from the PowerShell gallery versus not. So in this case, we're creating a file share. And so if it's not Windows 10, we have to create that differently, because Windows versions of Windows prior to Windows 10 didn't have all the same great tools. So for example, to create a file share in Windows 10, you've got to use the net share command from the command prompt. If you are on Windows 10, though, they have SMB share commandlets with PowerShell, and you can use those, and it's a lot cleaner and easier to use that. So here, I'm basically structuring together a raw PowerShell command in this string, and I've got to do encodings and all that kind of crap. It's hard to read. But when we get down here, yes, question? Okay. Down here, if you are on Windows 10, we can use those SMB share commandlets. And so the first thing is I want to install the xsmb share DSC resource. And so I can do that with the install module command. And then once that's installed, I can use the xsmb share DSC resource. So technically, these are both using the DSC resource, but in this case, it's just doing raw PowerShell scripting, because I was showing an example of that. I could technically use an exec or execute resource. I forget the exact name, which comes from Chef. I could do that as well and do the same things. But just trying to show an example of writing PowerShell script. So in this case, you can see the script type is a script. So I have to build all that together. It's just any PowerShell script that you write. If you're familiar with DSC, you know that to create a DSC resource, you have to create a get script, a test script, and a set script. So really, what this is doing behind the scenes is it's creating a DSC resource just out of these script lines. But obviously, down here, when we get to use the DSC resource from the PowerShell gallery, it's much cleaner, much easier to read. We're just setting the name to logs. We're setting the path to the log folder variable, setting the access rights, all those things. So much easier to read there. And so a lot of times I'll get the question, well, which one should you use? And to me, it's just a pragmatic question. Which one's the easiest to use? If the Chef resource is easier to use that. There's no real big reason to use the DSC. But you can imagine when you look at installing SQL Server or an Exchange server, writing a DSC resource for that, or using one that's already out there would be much easier than trying to do all of the configuration steps involved. So that's some examples of some DSC resources. Just one more example. So we saw this one above for the log folder. That was the Chef directory resource. Down here, I create a directory using the file DSC resource. So again, just two different ways to do the same thing, and it really just comes down to preference of which one you want to use. Any questions on that? Yes. This is all Ruby. Yep. Yeah, so that's a great point. A lot of people get scared off by Ruby. There's a really great blog post on the Chef website called something like "Just Enough Ruby to Do Chef." But I mean, if you've done multiple programming languages, it's variables, if statements, loops, all these things. It really wasn't tough to do that. Any other questions? Yes.
Underlying changes to stuff like XSMD share require you to go back and refactor your code at all, or have you found those fundamental modules to be pretty solid?
They've been pretty solid. Yeah. Some things are obviously harder to do than others. Yeah. But, so this is just some sample code. At work, though, we've got one that we use for our web servers. So it installs all the Windows features of IIS and WCF and all those things. And it creates our main data folder and our log folder. So we're using it in production. Yeah. We use TFS as well, and we do a bunch of testing inside of TFS. And so we have a cookbook for configuring the test agent where, Team Foundation Server on-prem. So definitely different ways to use that. I'll go ahead and mention, a lot of folks are looking at Docker now. And a lot of people ask, is Chef really still valuable with Docker? I think it's less valuable. It seems like the Docker Compose and the Docker files themselves do a lot of this type of work, so it's not needed quite as much. I'm wondering if Chef doesn't come out with some way to interact better between the two. But at the end of the day, we're always going to have servers that we need to configure. It may be the Docker host, or maybe SQL Server or Exchange, things that we don't want to put in Docker containers. So we still plan on using it. Any other questions? All right. So unit testing. So this was kind of the thing that I thought was unique to this talk. I saw a lot of people talking about Chef and automation configuration. I did not see a lot of people talking about how to test it. So just out of curiosity, how many people are doing unit testing or integration testing of some type? All right. So I'm going to tell you why that's important to do and brings a lot of value. So before we get into actual unit testing, I struggled when we first started looking into this. We had some other guys at the company that were using it. They were more on the Linux side of things, but we wanted to use some of the same frameworks on the Windows side. And so I started to get into it and probably spent 6 to 8 weeks trying to get it to grok and to understand it. And it wasn't clicking, And then I found how to use Chef Spec for unit testing and Kitchen for integration testing. And that's when the light bulb went off. So being able to validate assumptions and really understand how things are working behind the scenes was really the key point there. And the testing helps you to better understand what Chef is actually doing behind the scenes. And for me, at least, it ramped up that learning curve a lot faster when I started doing that. So that's at least one reason. Beyond that, it's about code quality and making sure that we can validate that our configuration code is going to work as we expect it to. So let's kind of get into the details here. So the first level of testing that we'll talk about is unit testing. And so the tools that we use for that are Chef Spec, which is the unit testing framework that Chef comes with. That in turn is built on top of our spec, which is a Ruby unit testing framework. So basically, Chef has provided Chef Spec that has an execution engine for the unit tests, and then a bunch of helper methods and classes to use along with that. So that engine, that Chef Spec engine, provides a sandbox. So the whole point in unit testing is to not actually do all of the steps. It's not an end-to-end test. If you're doing C# development, for example, the whole point is to isolate the one method or the one line within a method that you want to test, and kind of isolate it, put it in a sandbox, and run it just in that context. You mock any dependencies or anything like that so that you're only testing that small bit of code. That does several things. It makes it much faster to run that test because you don't have to rely on a network or the file system or any of those things. It also it runs faster. It helps you isolate to that code, so there can't be unintended consequences, right? If the server is down, SQL server is down, or if the file system isn't set up correctly or the permissions aren't right, it may not work reliably from one developer's machine to another or on the server or any of those things. So unit tests help to isolate the code and test it in a much more reliable way. An example of that in our C# code that we test, we run all of our unit tests when we check in the code. And that takes maybe 5 minutes to run thousands of unit tests. We have hundreds of integration tests, and those can take hours to run, and they're far less reliable. So it kind of gives you an idea of the unit test. Because they isolate down, they mock dependencies and things, it makes those tests much more reliable over time. So the same thing in Chef, we can write unit tests to isolate down to a given recipe and validate the code within that recipe. So part of what it provides is that engine, that Chef spec engine that creates that sandbox that you can run the recipe in, and then it evaluates your unit tests. Provides some syntax checking, helps you to verify logic and guards within the recipe. You can validate expectations and properties as well. It reevaluates the cookbook on every unit test run by default, just to avoid any kind of shared session between the unit tests. And then again, it uses PowerShell to fulfill all the dependencies in the context of the unit tests. So let's take a look at that. So I have a spec folder here and unit tests, and then under recipes, I actually have my unit tests here. So this is a unit test for the recipe we looked at a moment ago. And so the first thing you'll see is got a require at the top for spec helper. That's just another file here where I've got some shared code that I might need across all of my unit tests. So it's just a way of keeping your unit tests dry so we don't repeat ourselves. And then we also require another class that's in here, I think it's under libraries, website binding. So just a way to reference code that you need to pull in. And I'm going to skip some of these for a second, and we're going to look at this let chef run. So this is a kind of a lazy loaded method. I don't know the exact term to use for Ruby, but basically it's saying when you reference the chef run variable, do the stuff inside of this block. And what it's going to do is it's going to use the chef spec solo runner, which is part of that chef spec framework, to create that sandbox, that unit testing engine. And we're telling it we want it to mimic or mock a Windows platform in a specific version. And then we want to, once we've defined that runner, we want to call converge on the runner. And so converge is a step where it actually applies the recipe to this sandbox, and then it evaluates how it ran. But you saw this was a variable for version. And so if we go back up, you can see that we're defining that inside of this Ruby loop. And we're saying we actually want to run all of our unit tests against 2008 R2 and Windows 10. So that's an easy way that you can define multiple sets of unit tests and then run those against various versions of Windows. So then after that, we've got a describe block. So if you're anybody familiar with Pester? A little bit. So some of the same naming conventions here. Use a describe block to describe the cookbook and the recipe that you're testing. You can further subdivide the unit test with a context statement and further description of what it is you're actually testing. The before do is setting up some mocking. We probably won't get into that too much today. And then finally, I set up my cookbook name. So that's all set up for the unit test, and then we actually get down to the unit tests themselves. So in this case, you use the it command, you give the test a name. So in this case, we're expecting that the chef unit test run will not raise any errors. So in that case, we say expect the chef run, which is a reference to my lazy loaded variable up here. And we expect that to not raise an error. So this is a method that comes with chef spec, one of those helper methods, and this just makes sure that no errors are thrown. So that one's kind of benign, but if we look at the next one, this is the unit test for the resource where we create our logs folder. So same thing, we call expect chef run, and we expect it to create a directory, and we expect the resource name to be log folder, and we expect it to have some properties, specifically path and C logs. So this particularly I want to point out is what they call a resource matcher. The last part is the resource type. So directory was the resource type, and then this first part is the action that we're performing. So we're calling the create action on the directory resource. So if we go back to the log folder resource, you can see we're giving it a name, which matches this one. And we're calling a directory resource in the create action. To create directory. And then we provide the values that we also want to test against for path C logs. That's a basic unit test, an example of what we're doing there. So this type of unit test is really helpful when you're first learning Chef. Once you've kind of gotten into it and you really understand it more, this probably has very little value. You're just validating that the path is set to the same thing. So I would suggest doing this when you're first learning it, but after a while, it's probably more work than it's worth. What's probably more valuable is to do some of the conditional logic testing. Question? Okay. And so in this case, when we saw the code before that was doing the SMB share creation, we have to mimic that logic. And so it is probably valuable to have unit tests around the logic to where we only want to run this XSMB share resource if it's Windows 10. Else, we expect to do the net share manual PowerShell, right? So those are kinds of things that you would probably want to add unit tests for, because if somebody comes behind you later and is editing the PowerShell or the Chef recipe or cookbook, they may say, well, I don't understand why I did that, and get rid of it. Or maybe they have things called guards. There's various types of logic in there. You want something to be there to kind of make them take a second look or think twice about just deleting code that they don't understand. And then this is also helpful when you get into more complex logic structures where if it's Windows 10, I need to do one thing. If it's Windows 8, we need to do three things. All of the validation that you need to do, the assumptions that you need to validate. So let's see. So to run this, remember how I said that the Chef DK comes with everything you need? We call those things that we need that are embedded into the Chef DK by calling the chef exec command. That basically says run this Ruby command. And so in this case, chef spec is built on top of RSpec, so we want to run RSpec. So this is going to go into my, notice I'm in the cookbook folder, or my Acme WinWeb folder. And it's going to look through that directory structure, find all of the spec files, and run those. That can take a second or two. So while that's running, we'll come back down and look at a couple of others here. So here on the data folder, so this is the unit test where we use the DSC resource to create the data folder. So same type of thing, expect chef run to run DSC resource. So the resource is DSC resource, the action is run. And then we give it the attributes that we expect that resource to have. We want the resource to be set to file, and we want the destination path to be data and the type to be directory. All right, so back at the execution. So it took about 26 seconds to find all the tests and run each of those. And you can see we had 12 examples and 0 failures. So let's cause a failure to make things a little bit more exciting. So all I did was I changed this folder to data 2. I did not change the recipe code. So when this runs, it's going to be expecting to see data 2, but that's not what the recipe is doing. And so it'll give us some different output here and tell us we have at least one failure. I didn't mention at the top, there's just some warnings up here about some PowerShell changes that are happening. So in this case, we have 2 failures, one for 2008 R2 and one for Windows 10. So remember I said that each of the unit tests is going to run for those 2 versions of Windows that we defined in the loop. So it's failing for both of those, and you can see kind of, no, that's worse. Let's see. So it's saying it expected the DSC resource to be data 2. But now I can't see. But it was, oh, there it is right there. It expected data 2, but it actually was just data. So if we go back and undo that change, and rerun our tests, it should all go green again. All right, so that's unit testing. Questions? Anything? All right. So the next step of testing that you'd want to do is integration testing. And so that's where we're actually going to be applying the cookbook to an actual node. In this case, we want to create nodes dynamically on the fly, and so we're going to create virtual machines for that. And so Kitchen is the integration testing framework that works with Chef. And there's basically 3 steps to a Kitchen run. There's the create, where it creates the virtual machine. the converge where it applies the cookbook or whatever you tell it to the virtual machine, and then a verify step where you run your integration tests. And so for each one of those kind of steps, there's different providers or implementations that you can use. So for the create step, by default, when you get Chef DK, it assumes VirtualBox. So if you use that before, it runs on both Linux and Windows, and allows you to create virtual machines with the VirtualBox executable or application. It also will work with Vagrant. Vagrant's really cool. Anybody use Vagrant? Go out and look at Vagrant. So Vagrant is like a registry of virtual machines, of known images and things. And so it makes it super easy to go and find someone else who's already created a Windows 2008 R2 with SP1 image, and you can just download that and run it on your machine. Or if you want some specific distro of Linux or whatever it is, Vagrant has a registry of all those things. You can create your own and upload it. It's really, really slick. So Vagrant's one. In this case, I'm using Hyper-V because I'm on Windows 10 and have Hyper-V. So really, you just pick which one you want to use. There's also cloud options. OpenStack is an on-prem cloud framework or platform. You can use Azure. You can use AWS. Any of the major virtualization platforms or systems are there. For Converge, the basic step that we'll look at is the Chef step to Converge. But one thing that's really cool about this is Kitchen can be used with things other than Chef, like PowerShell. There's some really good, do you know who that was? Somebody in the PowerShell community was showing how to use Kitchen with PowerShell scripts. So if you're using DSC or you just use PowerShell scripts for a manual server configuration, you can put those and use that with Kitchen. So everything I'm showing here, you can do all the same stuff with PowerShell scripts. So even if you'll never use Chef, Kitchen is still a great thing to look at to learn how to test your PowerShell scripts. And then lastly, the verify step, you can choose different integration testing frameworks. I mentioned InSpec is the one from Chef. Pester is a PowerShell testing framework, which is what we'll use. And then finally, the fourth step, which is there, but it's not really one of the main steps, is to destroy the environment so that you can do it all over again in a fresh environment. All right, so let's take a look at that. So the first one we'll look at is this kitchen.yaml file. So this is a configuration file to tell Kitchen how to run. And you'll see it has all the same information that we just went through. First, you got to choose a driver, and that's the virtual machine provisioner that we want to use. So in this case, I'm using Hyper-V, and then I got to give it information about how I want that virtual machine created. I've got to give it the virtual switch I want to use, the VHD folder and name, the username and password I want to use for that image, and then how much memory to use on startup. Next, we have the transport, and really the two options here are either SSH, which you would likely use for Linux, and then WinRM for Windows. And then further information about how to connect to that. I'm using the same username and password and using elevated privileges. And then the provisioner is Chef Zero. This is where if you want to use it with PowerShell, there would be a PowerShell provisioner of some type, or maybe it's a Pester. I've never looked at it myself. But there's all kinds of things. If you're familiar with Ansible, there's an Ansible provisioner as well. Ansible is similar to Chef. It's a infrastructure configuration tool. Then we get down to the listing of platforms, which is which types of virtual machines do I want to run my tests on. So I've got several defined here, one for Nano, one for 2016 Core, one for 2016 just minimized, and then one for 2008 R2. And so for each one of these, I can override some of these configuration values that we saw up at the top. So in this case, on the provisioner for Nano, I've got to give it an AppX because you can't install MSIs on a Nano server. Down here, I think these are basically just different virtual machines for each platform. So just different ways you can override that. And then lastly, I give it the list of integration tests that I want to run. So here I'm telling it, I'm giving it a name and then saying I want to run the Pester test for my default recipe. So if we look over here in the test folder under integration and then my cookbook name and then Pester, we have my Pester file with my integration tests. So here again, kind of similar, you can use a describe block to start everything off. You give it a name. And then you get into the actual unit test with the it command again. And so now this is PowerShell code, right? So everything before this was Ruby, but because we're using Pester, this is all PowerShell. And so here again, we give the test a name, and then we just use PowerShell scripting to identify something we want to test our assumptions against, and then use the Pester commands to evaluate that. So in this case, I want to validate that the C data folder is created and the C logs is created. Again, on the net share. If it's less than Windows 10, I want to validate that SMB share exists. So I use the net share command and then make sure that that's not null. And then further, I test the permissions on that. So to run that, again, we go to the command prompt and we say kitchen verify nano. So we haven't shown the other steps here, but just like the other steps that we went through on the slide, you would call kitchen create to create the virtual machine, kitchen converge to apply the cookbook or converge or apply whatever thing you're testing. And then you run the verify for it to go out and find your verifier and run those tests. So in this case, it's connecting to the virtual machine that I have running. And you can see that it found the two tests. In this case, I'm running on Nano, which is a version of Windows 10. So it only ran the two tests here. This one was for if it's less than Windows 10. So just real quick, I'll show Hyper-V is here, and I've got my Nano server running with 3 gig of RAM. It's got an IP address and memory. All that's there. So at this point, I've got a basic recipe that I've created. I've got unit tests, and I've got integration tests. This is where, okay, I'm ready to add the next feature or the next configuration to my server. That's where you want to start thinking about testing and testing first. That's the whole idea behind test-driven development. And the reason is by doing the tests first, we validate that the code that we're adding is going to work. If we write the test afterwards, we could write a poor test that doesn't actually test what we think it is, but we never saw the tests fail, so we don't know that it's working. So the way that we would do that, to take a test-driven approach, is to write the integration test first. So here I'm back in my Pester file. I'm going to add this test for should have a registry key set. And it's going to validate that this software test foobar key should be set to 0. So I save that. I go back. I run Nano again. And so what's going to happen? Anybody? It's going to fail. Why? We haven't run the configuration yet. But by running it this way, we know that because the test is failing, it's potentially a valid test. If we first see this test fail, and then later we see it go green or succeed, we know that it went from a state of not working to working, so we've therefore validated our test. So now it's running through. The first 2 ran successfully, and then it got down to this one, and it said, oh, we had a problem. We expected that key to be set to 0, but it was actually nothing. It didn't exist. So we had a failure on that line. So now we know that we have a properly written test that will test that key is created successfully. So now we have an integration test. So what should we do next? Do it? We not yet, though. We want to write a unit test. So we write integration test, see that fail first. Then we write a unit test, see that fail, and then finally we'll write the actual chef changes. So here again, we'll come down to the bottom and comment this. We're going to add some unit tests for, while that's kicking off, I'm going to go ahead and execute that. So here we're going to expect the chef run to create a registry key. And actually there's a bug in here. These should be strings. That's okay though. We're expecting a foobar key to exist under HKey local machine software test. And then, so these are 2 of the same thing. So when we do it in the recipe, we're going to do it both ways. In this case, I've got to test it both ways as well, though. So in this case, I'm creating the registry key using the registry key resource in the create action, right? In this case, I'm doing it with the DSC resource and the run action. But it's all the same information. The name is foobar in both cases. The value is 0. The type is string. It's all the same thing. So now if we look at our test, we can see, oh, it failed. It failed 4 times because we added 2 unit tests that we haven't implemented the code for yet, right? All right. So now we have integration tests that are failing. We have unit tests that are failing. Yeah. Absolutely. Absolutely. Yeah. So you can't just see it's red and assume that's right. Yep. Exactly. Yep. In this case, because we're doing the test first, it should fail first. It should, but you got to look at more than, oh, it was red, I wrote it right. You got to see why is it. And so in this case, you can see it expected an action to run. It's hard to see. Expected registry key with action to run to be in the chef run, but it didn't see it, but it did see these. So that's kind of, it does list them out, which is cool, because then a lot of times you name it wrong and it's using the name of the resource. But in this case, these are all good. So now we can finally go back to the recipe and add these resources. All right, so again, save that. Go back and rerun our tests. That'll be fun. Okay, so in this case, again, we're using the chef resource called registry key. We're giving it the path to the registry key that you want. You can name this something more descriptive, or you can set it to the actual registry key path. It'll accept either one. If you want to set it explicitly, you can do that as well. And then we're giving the values of the name of the key, the type, and the data. And then we do the same thing. We create the same exact registry key with a DSC resource. So here we're using the registry DSC resource from the PowerShell gallery. Well, it's actually installed with DSC. We're setting the key, path, the type, and the value name. That make sense so far? All right, so let's look at our tests. Looks like it failed again. But to your point, it's a different error this time, right? So in this case, it's saying, okay, it expected foobar type of string, but I forgot to change the type name in the resource. So this is a perfect example of how by writing the unit test first, we've caught something. We know the unit test is right. We intended for that type to be a string, but we wrote the resource wrong. So here, if we change this to string, and go back and rerun, hopefully our unit tests go green. You see this last time, it took about 13 seconds. This will take about the same. Assuming we did everything right, it should have 20 unit tests, all successful this time. So we get the warnings again. I don't care about that. And each of these dots represent a unit test. And now we have, I was adding the two together, but 16 unit tests that are all successful now. So now we've run our unit tests. We've run the recipe in the context of the chef spec sandbox, but we haven't actually run it against the virtual machine yet, right? So to do that, we've got to run the converge step. So here we say converge. We already have an existing virtual machine, so we don't have to go back all the way to the create step. It already exists. We're just adding something to it. So we can just call kitchen converge nano. I'm telling it nano specifically. I want to do just that one. If I just say kitchen converge, it'll try to run the test for all of the suites for 2008 R2 and 2016 and everything, and that would take far too long. All right, so now it's going through. In this case, it's resolving the cookbook dependencies with Workshelf. It's transferring my cookbook to my virtual machine. So it's copying those files over. It's using WinRM as the transport to copy everything over. Once the cookbook is there, it'll run the chef client. Mm-hmm. So that's really more about the testing framework itself. Yes, you can hose a VM. No question. Right. What's from scratch? The virtual machine or the recipe run?
The virtual machine is running.
Yes, that's correct. Yep. And that's, I'll show you some timings of how long it takes starting from create all the way through verify versus once you have a virtual machine, the feedback loop is, hey, I get it running the first time, and then I iterate on that and add more and more things. And then from that point, all I have to do is the converge and the verify. All right. So it resolved all the cookbooks. It's got my list. Some of these other ones are just some of the dependencies that the PowerShell. So I depended on the PowerShell cookbook. It in turn had dependencies on these other things. So it uploaded all of those. It ran the cookbooks. And you can see for most of these, it said up to date. So one thing about infrastructure automation is you want it to be, crap, I forgot the word, idempotent. So you want it to be able to run many times and not have an effect if it's already run in the past, right? So when we look at the DSC script and we see the test script, it runs the test script to know if it needs to run the setup script. So that's part of the idempotence there, is you want to be able to run it many times and it be smart enough to know, do I need to run this or not? So in this case, it knew that the directory, it looked at the directory, and it's all just built into the resource. When I say I want to create a directory, that resource knows how to go test to see if it needs to create that directory. So you can see most of these were up to date because we had already run all of those, but then it got to this one and it created the registry key. Then it got to the next one, which is trying to create the exact same registry key, and the DSC resource knows, hey, no, that thing already exists. I don't need to do it. The first one did it, so I don't have anything to do. So now that's been converged, and I can run verify again. And hopefully, if we did everything right, everything will go green. We'll have 3 successful integration tests with Pester, and we will have completed our test-driven development cycle for adding a new configuration to an existing recipe. The same thing, it's copying all of the tests over to the virtual machine so that it can run Pester there. It's transferring the files. It's running the test, and everything's green. So we've gone through that. They call it the red, green cycle, right? You want to see it red, you want to see it fail first, and then go green. In the context of development, usually the first red, green is your compilation step, and then the second is your test run. So it's compilation and then runtime. In this case, it's applicable because we want to see the integration test red, and then really the unit test red and then green, and then the integration test red and then green. So we've now successfully added those all via test-driven development. Any questions before I keep going? Cool. So just to give you an idea of kind of how long it takes. So remember I talked about how unit tests are much faster, right? In this case with Kitchen, it's got to create a virtual machine, which depending on what kind of image you're using can be really slow. So for 2008 R2, that's a 20 gig virtual machine image. And so because it's so large, it takes quite a bit more time to create that. And so just to create it in Hyper-V is about 3 minutes, 2 3/4 or 3 minutes. Then we've got to run the converge step. And in this case, we've got to run it multiple times because it's 2008 R2, it doesn't have PowerShell 5. We have to install PowerShell 5, and then it has to do a reboot because it's part of the install process. So we then have to call converge again, and it does a couple more of the resources. And then finally, it runs the verify in about, the converge, the first one took almost 4.5 minutes. And that's mostly the PowerShell install. And then secondly, it created the directories and the SMB shares and all that kind of stuff. And that took about another 50 seconds. And then from there, the verify where we're running Pester took about 37 seconds. So to go through soup to nuts, everything, it's about 10 minutes to go through that whole process. But just like we saw and just like we did, once you have that up, if you just want to add one more thing to the recipe and create the integration test, see it fail, create the unit test, see it fail, and then create the recipe, that's quite a bit faster. It's like 60 to 90 seconds to go through that cycle. So it's all part of getting that quick feedback loop. If you host the VM, you got to go back from scratch and start over again. But it's so nice to have Kitchen that just automates all of that for you, right? And it's not just on your machine, it's all standardized. So anybody who's working on the cookbook with you As long as they have the Chef DK installed, they can do all of the same testing you do. So it's super, super valuable. So to compare that, I'm using Nano because it's much smaller. So it's about a 600 megabyte virtual machine. And it only takes about 40 seconds to create. It still takes almost 4 minutes to converge, and then about 6 seconds to verify. So, but it's about half the time in that case. So about 5 minutes to go soup to nuts, and about 30 to 40 seconds to do that cycle of development. So we already kind of looked at Pester. Great tool for testing. Everybody should be testing the PowerShell scripts. I promise it's so much faster than trying to validate those things manually, log onto the server or do it over a PS session. It's much, much faster to do it this way. And then you can ensure that anybody who's working on this thing after you hasn't broken any of your assumptions that you made with the PowerShell script. So definitely suggest doing that. We've already looked at the kitchen demo. These are just some of the versions that I'm using. So Chef moves pretty quick with new versions. I'm using 2026, and I looked today, and they're already at 3.1, but it's mostly just they included a new version of Git. So no big changes, but the 2.0 release was a big release. They made a bunch of improvements there. I'm using Hyper-V on Windows 10. I'm using PowerShell 5.1, Pester 3.4, DSC 1.1. You also want to make sure Ruby uses gems to pull in dependencies and things. Those can get kind of hairy. So I'll show Chef Exec. I think it's a gem list thing. You can see all of the gems that Chef installs. You can install new gems if you need it. So those are all the ones I have on my machine here. But then I can filter that further, and I want to see all the ones that have to do with kitchen. So for this one, I had to install, I think, the Pester kitchen. Let's see. So I think I installed Kitchen Pester and Kitchen Hyper-V in this case. All the other ones were there by default. So in these versions moved pretty quick. That was one big change coming from a more C# development background. These things move all the time, and they can get in conflict with each other, which is another reason why the Chef DK is so valuable, because they've done all that testing. They've packaged all of these gems together, and they're saying, hey, we know that this set works, right? So it's really, really nice to be able to have that. Yeah. Yes, question? No. So I've gotten that question before. We're not using any encryption on the password because it's just a local virtual machine. If you needed to, because you're going into Azure or the cloud, there are providers to do that, but I just didn't need it in this example because it's all just test code. So let's see, let's look at this. Are you talking specifically about the? So you wouldn't use the Ruby scripts in production, right? You would make this part of your development or your deployment. Yep. So it's only for testing. Okay. So the unit test, integration test. I think I see what you're saying there. The Chef cookbook itself, right? That you would upload to the Chef server. You would version it and upload that to the Chef server, and they have encryption, and you do that over SSL and all that kind of stuff. So, and what's neat though is you wouldn't put any passwords or anything like that in there. I don't know if I have an example of this, but they have what they call attributes. I don't think I have an example. And an attribute is it's key value pairs that you set up on the Chef server, and you just reference them here, right? So it's just a key value store that you can use. And for testing purposes, you would just give it mocked up data, anything you want, just to validate that it's pulling from the my secret test attribute. And that's what you want it to use in the code. So yeah, good question. Let's see. So those are the versions. All the code is on my GitHub account, bit.ly/tddchef, if you want to look at that. Just some other quick troubleshooting things. If you're getting weird errors, you're not sure why, you can add the debug log attribute there on that top line. to get more details about the chef run itself and see what's happening behind the covers. I've used that quite a few times. Validate your gem versions. You might need to get the latest version of Chef DK. I've had that happen a couple times. Like I said, everything's changing. The gems are changing. The Chef DK is changing. The public cookbooks out there are testing. So one of the things that Burkshelf does is when it downloads it, it locks it. So there's this Burks file lock. And so this tells you what it went out and found. And that's what's going to keep using unless you delete this file, and it's going to go get them fresh again, right? So there's, I don't know if I have it. You can specify and say, I want this specific version. If something, and that's what happened in this case. They made some changes to the Windows resource, and all of a sudden my stuff started failing. I wasn't sure why at first, and then found they made some breaking changes in 3.0, and I hadn't told Burkshelf I need something less than 3.0. And so to fix it, I just had to go add that directive in the Burkshelf file to say, I need the Windows resource, but I need some version less than 3.0 to get that working again. Sometimes destroying and recreating the VM just fixes it, which I hate. You know, it's like, just reboot the server and everything will be fine, and then it fixes it, and like, I don't know why, but that's so. I hate when that happens, but there's been a few times where Hyper-V has just stopped working. Looking back, I think most of those were probably I was out of memory, and it doesn't say you're out of memory in the error log. It just gives you some weird error. And so by rebooting, I closed all my programs, and then it worked all of a sudden. So definitely check that. I've seen that a few times. Networking can be an issue with your virtual switches on Hyper-V specifically. I've seen that a few times. I wrote a couple blog posts on that to make that easier, hopefully. And then I always like to give a shout out to Matt and Steve because they helped me work through this, and they're still both very active in the community. They have a Slack group. They have an IRC chat. So lots of different ways to get in contact with the team. These guys specifically for working with Chef on Windows. That's it. If you have any questions, we can field those now. If you think of something later, hit me up on Twitter. I've done quite a few blog posts on Chef on my blog, .netcatch.com. And I think that's it. Appreciate everybody's time and coming out. Hopefully, who thinks they'll use Chef? Who thinks they'll use Kitchen with PowerShell? More hands, more hands. Cool. Any other questions? Oh yeah, yeah. It's kind of crazy. And so what's neat is if you look at my Hyper-V images, the Nano one I created myself. The 2008 R2 one though, you can create them yourself, but it's a pain in the rear. And so what's a lot easier is I'll go pull down the Vagrant image, which is a VHD, and use their image, but use it just straight out of Hyper-V. So it's just another great way just to find images that you need. But yeah, if you go to yeah, so it's the eval versions that Windows puts out. Let's see, Vagrant boxes. HashiCorp is the company that built that. Look at this one. What is it? .com. So Vagrant up is the command that you use to spin it up. I used this for a while when I was back on Windows 7. It worked like a champ. It was really, really nice, and I ended up using it for all kinds of other stuff. Yeah, so there's an example of the commands. They've got a listing of all the boxes somewhere. Find boxes. It's the big button on the right. There we go. Yeah, so if you're looking for some weird version of refresh the page, I'm not sure what's going on there. In most cases, you'll find multiple versions of or options for different images. So yeah, so Windows 7 with SP1, x64. This is a pretty neat tool. Good question. Anything else? Awesome. Thanks for coming out, guys. I appreciate it.